that we have been doing. Okay. Can you all see my screen? Can someone confirm?
Yes, sir.
Okay. Yeah. So we were in this particular slide where we talked about these different reflectors, and and of course we talked about the general structure in terms of the faults. We said that this is the basement and this is the basement, and then of course these are the sedimentary layers. Yeah. You can also observe some sort of growth happening here too. You can see that the sedimentary thickness, of course, increases, decreases as we are moving away from the fault, and this happens because of, since syntectonic sedimentation. Okay, we said growth is due to syntectonic sedimentation. Now, if I ask you to find out the traps, okay, so that is something that would be another job for you. Okay. So, for example, we don't generally expect to have hydrocarbon in the basement. Okay, because basement is generally out of metamorphic rocks. Okay. So metamorphic rocks do not generally contain a basement. So we have to look for the sedimentary strata here. Okay, that is where we will expect hydrocarbon. Okay, so where can we find hydrocarbon? And you can see there is no obvious anticline developed here, right? So if you don't have any anticline developed, then you have to depend on fault dependent traps. Okay, so for example, these could be your potential traps, right? This could be your potential trap, because you can see that if there is a if there is a shell which runs, if there is a shell which is forming your cap rock here, you can prove that then this could be one of your traps. Okay. Similarly, there could be a trap here, and so on and so forth. So they will be generally fault dependent. Okay. Uh, So they for fault dependent trap, there are two things that we need to look for. If I generally find out that the strata is kind of horizontal, okay, and then there is fault, you don't expect this to be a good trap. Generally, you have to have a nice dip on your beds, and then it gets dissected with a fault. Then you find better traps. So these could be my potential traps in this particular example. Okay. Now let's go through some more seismic. Now this is a fairly complicated seismic, as you can see, and this is already interpreted. And if you kind of think that if the interpretation is removed, it's fairly difficult to understand what is going on in this particular case. Okay. And here also you can very nicely identify that perhaps this is my, you know, this this red line, yeah, which itself is extremely dissected by faults. Okay, this is perhaps your basement. So how would you identify basement? You will identify basement that the seismic quality, you know, drastically changes from the sedimentary layer to the basement. Okay. So what you generally observe in the petroliferous basin, that you have a metamorphic basement over which you have sedimentary rocks. Okay. Over which you have sedimentary rocks. Now, this is where you will find oil and gas. In the sedimentary rocks, you will find oil and gas, right? Now, how would you identify metamorphic basement? That my seismic quality, okay, drops drastically, yeah, over the metamorphic basement. And then it actually loses that beautiful layer cake structure. So you can see there is beautiful layer cake structure before, in all these strata. You see beautiful layer cake structure, but then after that you don't actually have nice layer cake strata. Yeah. Of course, now you can identify few unconformities as well. For example, this is perhaps one of your unconformities. This is one of your unconformities. Here is also another unconformity, as you can see. This is also another unconformity. Just by looking at the structure, you can identify that there are unconformities. And here you see these are my wells which are being drilled, and let us see where they have drilled these wells. Now there is a very mild structural anticlinal trap being developed. That is where they have drilled it. Okay. So they thought that these are perhaps your traps. Now perhaps they have drilled a well here as well, because you see it's a nice antiform being developed. Okay. They have drilled there. Okay. So you can see, of course, here that how beautifully, you know. So this is my sea floor, right? At the very top, you have my sea floor, and you can identify that this part is perhaps onshore, I mean, above the sea. This is onshore. This is perhaps the slope. This is perhaps the shelf, yeah, and then this is my deep sea, where um, the sea bottom becomes more or less flat, and then there is this sedimentary strata at the very top, yeah, which is pretty much dissected by faults. And you can how do I identify that this strata is fairly different than this strata, because you can see that the faults completely dissect. So if I say this is A, this is B, then these faults completely dissect the B strata, but the A strata is kind of undisturbed, right? You can identify here as well that the faults are of normal type, right? The normal faults. Within A strata itself, also there is a boundary which we just talked about. Is my another unconformity. So this is unconformity one, the unconformity one, this is unconformity two, right? So this is how you essentially uh, talk about uh, different zones here, right? Now let's look at this one, and let us try to interpret this particular seismic section. Okay. For your exam, what you can expect from a seismic section is to make a uh, is to make an interpretation like this, and then to identify different traps. Okay. And you can be creative. I mean, there is no unique answer. You can be creative in identifying traps. Okay. So now let us see. Let us first, if this is a completely unworked section. So let us try to identify different zones first. Okay, so you can see here we can broadly identify that there is very beautiful, I mean, all the way up to this. So the first thing we will do, we will try to demarcate our, we will try to demarcate our sedimentary zone from the metamorphic basement. Okay, so you see here up to this, you know, all the here all the way up to these. Yeah, I have nice, beautiful, layer cake stratigraphy preserve. But somewhere here is the boundary where my layer cake stratigraphy is kind of missing. So here is my basement, and in the other side, perhaps here is my basement. Okay, so if I just move this part, you now can identify your basement. Now we have figured out my basement. Now what I can see that, you see, this, with your trained eyes, you can actually understand. Now you have to give me a little bit. And you see, this was here, the same horizon. That's the top of the. So as if this was this A point and B point were together, right? Now A has actually slipped up. Okay, A has actually slipped up. So what we can say that there is perhaps a thrust in here, right? There is a thrust. So as if this, you can slowly bring down point A to point B, and then you will have this whole stratigraphy, your basement, and basement will match too, right? So there is one thrust here, of course. Okay. There is one thrust here, thrust plane. And then, of course, there is another thrust which accompanies this one. You can see, you can observe. So now if I try to draw some horizons, if I try to draw some, reflectors, so maybe, this distance, and perhaps is the same as this distance or more. So perhaps this is the same horizon. So, this horizon and this horizon were together. And then there was a thrust, of course. There is also thrusting going on here. And then they have created these beautiful anticlines here. So, and then of course you can observe here beautiful faults. They are normal faults. You can see there is so you can observe that if I now try to draw this horizon, here is my horizon going like this, and then this is being displaced by this fault, okay, and then displaced by this fault, displaced by this fault. Okay, so I can actually keep on drawing here a number of faults, okay, which are of normal origin. They are all normal faults. Beautiful normal faults. So now if I ask you to identify traps, So one of the traps could be, one of the, without any other information, there could be a trap here, and the spill point will be somewhere here, right? Because after that it will go away. Now there could be a trap here, okay? There could be a trap here, and this trap will be fairly big simply because it will run all the way up to this. There could be a trap here too. Yeah, and it can be fairly big actually, because originally the spill point would have been somewhere shallower, but because of the presence of this fault, the spill point will go even below. And there could be some normal fault associated traps as well, perhaps here, 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 but they will be pretty small to actually drill. Okay. But these are fairly lucrative opportunities, simply because they are shallow. Okay? So you don't have to drill a very, you know, long well, and you can actually take the oil and gas out. They are fairly lucrative opportunities. Okay? Now, this is a comparatively easier section. Okay? You can see there is this fault, very nicely drawn. Okay? And this is the basement because it has lost its character. And you can see that these layers are kind of dragged against this fault, right? Dragged against this fault. Okay. Also, so this is the same client, so you don't expect oil and gas here, but here we do expect the accumulation of hydrocarbon, and these are my corresponding spill points. Now I can see one, two, three reservoirs one after another. So what are they called? Can someone tell me what are they called? If I see one, two, three, four, five, or multiple reservoirs at the so the idea is if I drill a well from here, okay, I can actually take out oil and gas from all these three traps. Okay. So what are these reservoirs called? Can someone tell me? I talked about it before. Hmm? Tell me.
Stacked reservoirs.
Stacked reservoirs. So they are called stacked reservoirs. Now let's look into more stuff. Okay. So you can see these seismics that we have been seeing so far now are of a new age seismic. I mean, as they are very beautifully uh, processed, and you can almost see everything. But in the older days, the quality of seismic would have been even worse. And people had to work with them itself. You know? You can see here one such example. So you can see that the thrusts are being uh, interpreted. So this is one, two, three thrusts. So why they are thrust? Because the hanging wall is moving up, right? Hanging wall is moving up. And if I ask you to identify the trap, so the trap will be, we use another color here, right? Would be a trap. and this will go all the way up to maybe here, right? There could be no, but I don't know because this is pretty much straight. So perhaps snow trap will develop here. Some trap can develop here. These could be your potential areas for hydrocarbon accumulation. Now this is another interesting one. So you can see here it's an anticlinal structure. Okay. This part of the seismic is not that great, but I can kind of interpolate them to look like this. And this is a typical box fold. Okay. You can see it's the anticline is not a typical anticline, but the anticline has a box-like shape. Those who have read structural geology, I explained why such structure actually develops, but those who have not, I will explain them later. They actually develop by a mechanism called flexural slip. And they could be excellent, they could be excellent traps. So if this green horizon is my top seal, right? So my spill point will be all the way up to this. This could be my accumulation of hydrocarbon. This is another one, beautiful thrust related trap. Okay, suppose if uh, this is my thrust, of course, right? You can see the hanging wall moves up. Okay, and if this is my cap, this is my cap, then I can expect the hydrocarbon column to go all the way up to this, right? Because that is my spill point, right? So here could be my accumulation. Not only here, I can also have accumulations here and form stacked reservoir. You can have stacked reservoir here too. So if I ask you to drill a well, you can actually think of being extremely creative and drill wells like this uh, and take out. But people do drill wells which are fairly complicated, which looks like this. Okay. You can see the structure can be very, very complicated. And this is a structure from, I think, deep water Borneo. And this is a typical fold and thrust well. This is called fold and thrust well. If I give you this section without the interpretation, you can understand it can be fairly complicated. Okay. And now, if I give you, this section, you can immediately identify that perhaps anything below this is basement. And then you can see there is a beautiful decolma. Okay. What is decolma? Decolma is a layer parallel thrust on which several thrusts actually rides. Those who don't understand, you can ask your friends who have already done structural geology class. They should be able to help you. You can see, so these are called toe thrusts. And then, of course, above this decolma, there are plenty of imbricate thrusts which develop. Okay. And then associated with that thrust, what I observed that my layer actually gets folded. So hence they are called fold and thrust well, because you see folds associated with thrusts. Okay. And they are excellent for hydrocarbon traps, right? And you can identify these spill points and fill your reservoir. And you can drill multiple wells from them and take out hydrocarbon. So they all could be potential traps. Okay, so that's all I wanted to talk in space of seismic interpretation. Let me ask anyone has any question. So expect that I will give you one or two sections and you have to interpret, and the sections will not be these. Okay. So will you be able to interpret these sections and then identify traps? If not, then ask me questions where you did not. All groups are not shared presentations amongst us. Okay, so please share your presentations. I mean, please do. It's part of your duty. Let me know which group has not shared it by the end of today. Then they will not get. They will be penalized. Okay. So by today, after the class, maybe in next 2 hours, you should circulate the presentations amongst yourselves, please. Okay, anyone has any question regarding interpretation? How these seismic images are obtained, of course, we will discuss in your geophysics class for third year, and rest of you actually should have a fairly good idea how they are obtained. Anyone has any question?
Sir,
Yes, Shivangi.
sir, if the area of the trap is too much, like I think in the second one you suggest, so you said that the chances of trap being there is very much low.
Where? Which
In
one?
Sir, the pink one, the pink and yellow one.
Here,
Uh,
this one. This one.
no, sir, below that. I think 31 or 32 slides, something like that. Hi,
This
yeah,
one.
yes, sir. Here you
Okay.
said on the you said on the anticline pole, you said the chances of being trapped there is still very low because of the spread, much more spreading area, something like that.
Well, no, never said that. It can be fairly large. I never said that. What I said that, in this case, in this particular area, if you look here, I will just explain that to you. If you look here, this is flat, na? So if it is flat, although it is kind of trapped by this fault, it can, it will not be trapped on the other side. So the lateral migration is not stopped. So I said this, although there is a fault at one side, it will not perhaps be a trap unless there is something on this side. Okay, that's what I said. But the trap can be as large as possible, no problem. There should be two things. To make that trap effective, one is you must have a top seal. Okay, you understand what a top seal is, right? It must have a top seal.
Yes, sir.
Okay. And then the spread of the trap will be all the way up to the spill point. Okay. So say for
Okay, sir.
example, suppose if this red layer itself, this is the whole top seal, and this sand layer is reservoir, then what I expect that this is my spill point, right? After that it becomes, the curvature becomes from positive to negative, right? So this will be, whole thing will be filled up by hydrocarbon. Okay, if it is filled to spill. If it is underfilled, of course, it can be somewhere else. The FWL will be moved up. But if it is not, if it is filled to spill, of course, it can go all the way up. So FWL can be here. So you have to identify the spill point. So that is an essential criteria to identify the spill point at each of these traps. Okay, and that's how I have drawn all the traps so far. Any example, if I take you through, okay, for example, here, how have I drawn that lines up? We said that perhaps this is my top seal. If I give you my top seal, okay, what I have to do, I have to find out this point. You see, this after this point, my positive curvature becomes negative curvature. So that is how I have drawn my graph. And I did not emphasize that properly because I thought you already know from the classes, from my previous classes, because that is how you identify your. So this is my fill point, and if it is completely filled with, sorry, so if it is completely filled up to the spill point, we call it a fill to spill structure. If not, we call it a underfill structure. Okay, is that clear with you?
Yes, sir, it's clear.
Okay. Anything else? Anyone? Anyone else? Is the right time to ask? Okay. If not, let's then go to another topic. And we are going to start some some introduction on your unconventional gases, and we will start with shale gas. Okay. So we talked about the conventional system so far, and in the conventional system, we have seen that you will require a reservoir, a trap, a source rock, a migration pathway, a cap rock, right? So these were my preliminary elements or must have elements in case of a conventional hydrocarbon system. Now, these unconventional hydrocarbon systems, which are there in the world, and we will specifically discuss three. We will discuss about shale gas. We will talk about, other than shale gas, we will talk about coal bed methane, or coal bed methane is also called CBM, and we will talk about tight gas. Okay, so we will, in the petroleum geology portion, we will talk about shale gas and tight gas. Coal bed methane we will discuss after we discuss coal. Okay, so we are going to focus on shale gas today. Okay, as the name suggests, these are gas reservoirs, and we find out we take out gas from shale itself. Okay, so in a conventional reservoir, what we have seen, that I will need a source rock, yeah, and then I will need a beautiful reservoir, and then of course on the top of it will be my cap rock, right? Here is my cap rock, okay, which will stop my hydrocarbon to go out. Okay. And we said the source, this is my reservoir, and this is cap rock. This is the conventional system. And we said hydrocarbon is actually expelled from the source rock, and this process is called primary migration, and then it moves up through secondary migration and fills up the pore space of the reservoir, and this is the conventional system. But in shale gas, what we observed, that this source rock itself, which is shale, you know, somehow contains the gas. Okay, it has the gas itself. So this layer itself works as a source rock, it works as a reservoir, and it works as a cap rock. Okay, so you don't essentially need uh, the presence of a trap, You neither need the presence of a separate cap rock. You neither need the presence of a reservoir. The source rock is there itself, and it acts as all these three. Okay? So you can simply drill in a shell layer, and you can take gas out. Okay, and that is what we call shale gas. And there is also one term which we call as shale oil, or the same thing. I mean, it's the same thing. Okay, the other name is liquid rich shell, where in such reservoir, such unconventional reservoir, we find, instead of gas, we find oil. So shale gas, shale oil, or liquid rich shell, the mechanism is the same. Okay, so you can club them into the same sort of reservoirs. Okay, in all of them, the type of the fluid actually changes. In all of them, you don't necessarily need this combination. You only have one rock unit from which acts as a source rock, which acts as a reservoir rock, and which acts as a cap rock. You virtually do not essentially need the presence of a trap, and you can simply drill through the shell and then take out either gas or oil. Okay? So hence it is called unconventional. Okay. So what is shale gas? Shale gas is a natural gas, of course. Okay. It's unconventional. I explained why it is unconventional. Found in certain type of shells. Okay. So what do I mean by certain type of shells? Okay. So these shells, of course, it has high TOC. Yeah. That's how it will expel hydrocarbon. Okay. So high TOC. And the second thing is, it has slightly higher permeability. Okay. Slightly higher permeability. Permeability slightly high. Generally, we find them in 2000 to 7000 deep reservoirs. Low permeability, of course. It's shale will never be as permeable as sandstone, right? So it's still low permeability, but maybe a little. It has a little uh, I mean, it has a edge higher, just a notch higher permeability. Okay. So around 2,300 trillion cubic feet gas in US. We will discuss what is it in India in a moment. But when shale gas has a very important had an important role to play in America's economy. So maybe before 20 years, maybe before 30 years, America used to export a lot of hydrocarbon from the Middle East. Okay. And then they changed their national policies. And then they said that we want to be actually self sufficient in terms of oil and gas production. But they did not have enough conventional hydrocarbon, oil and gas. Okay. So then they tried to look for alternatives. Where can we get hydrocarbon from, and we can actually meet the total energy budget of the country, but not essentially importing anything from elsewhere. And that's when they invested a lot actually on shale gas. Okay. And miles after miles, kilometers after kilometers were actually explored, and they started drilling wells, lots and lots and lots of wells. Okay. And then they started producing, of course. And then nowadays America doesn't essentially import any gas from outside because of the shale gas boom. They import a little bit of oil, but then they have become way more self-sufficient in terms of their hydrocarbon, in terms of their hydrocarbon consumption. They don't essentially. I mean, their dependence on other countries like Middle East have decreased drastically. In India, companies including Reliance Industries, okay, Reliance Industries Limited (ENP), RNRL. This is Reliance Natural Resource Limited, Vikas WSP Limited, and then of course I think I have forgot here ONGC as well right now. ONGC have expressed interest in exploring in India. I mean, they are currently also, I mean, they are exploring in India for the time being, okay, which is estimated to hold around 500 to 2000 trillion cubic meter of recoverable shale gas. So India has a huge reserve of shale gas, and in future when we say that the market of fossil fuel is kind of decreasing, but the gas price has not gone down. Okay, so we still, I mean, initially people were more dependent on oil, and nowadays as we are moving forward, because it has a low carbon footprint, people are getting more dependent on gas. Okay, as you can see, for example, when you were a child and in your hometown there were auto rickshaws which were filled with fueled by oil, right? But nowadays in all major cities you'll find no auto rickshaw that runs on oil. They are mostly they run on CNG. What is CNG? CNG is what? Can you tell me, anyone? What is CNG? I'm sure you heard about the name CNG, right? What is CNG?
Compressed natural
Compressed
gas.
natural gas, right? So that provides you an a key that people are, because it has low carbon footprint. If you burn gas, it is of course less carbon dioxide that is what you emit to the into the environment. So the demand of gas has started to increase in last 10 years or so, and more than oil actually. And then the relevance of shale gas, coal bed methane, and um, tight gas has also increased. So India is looking seriously into shale gas. Okay, so this is something that if you want to make your career in oil and gas industry, something to look for. So basins of preliminary interest, okay, in India are Cambay Basin. Cambay Basin is where already we explore for conventional hydrocarbon oil and gas. Okay, Cambay Basin, it's close to Bombay offshore Cambay, Gujarat. Then Assam Arakan Basin in the northeastern India, and then Gondwana Basin in central India. So Gondwana Basin in central India is also famous for its coal. Okay, so all these formations, like starting from Madhya Pradesh all the way up to West Bengal, you have plenty of coal fields, and they are all Gondwana coal. They all come from Gondwana formation, and they belong to the Gondwana Basin. Okay, and of course so there is shell. So there are also shell layers in the Gondwana successions, which seems to be also fairly fruitful for it has potential for shale gas. Okay. A lot of people are currently working on the uh, shells of Gondwana to identify their prospectivity. Okay. So how what are the issues or aspects regarding the extraction of shale gas? So leasing land, I mean, for drilling shale gas, you will see soon that you actually require to drill lots and lots and lots of wells. I mean, thousands of wells. That is what you need for unconventionals. Okay, so you need to actually build them somewhere, right? So the lands must be leased. Okay. So that starts. That is where it starts. Then you explore that area, okay, and then you drill. Okay, and this is a typical well. Generally, for shale gas, you drill horizontal wells. Okay, as you can see, the horizontal well, and then as the permeability of this shell layer is not very high, the hydrocarbon doesn't automatically come out. So because it's extremely low permeability, okay, what you have to do, you have to create secondary fractures. Okay. So like we discussed for leak of test, yeah, you create fractures in the formation. Similarly for Similarly, for shale gas, you also create fractures, but these fractures are I mean more robust than a controlled leak of test. But the principle is very similar. Okay, so you increase the weight of the fluid inside the borehole, and then you keep on increasing till it it crosses the minimum horizontal stress or fracture gradient, and you frac the formation, right? So, so because the permeability is extremely low, so this is one of the enhanced gas recovery thing that you have discussed in your slides. One of the groups. Okay, so here you enhance the permeability by inducing hydraulic fractures. Okay, and then of course you have to collect, then you have to sell. So then collect, then sell, and that is shown by dollar signs, and then restoration, of course. But once you actually drill it out, the hydrocarbon, you cannot leave that space like that. You have to essentially restore the land as much as you can to its originality after the field life. Okay, right. So here I wish to discuss also another thing. You know, this low permeability is uh, is the key. This low permeability is the key that makes this single reservoir, this single layer of rock being, source, reservoir, and cap. Because it is low permeability, the hydrocarbon cannot escape. So that is kind of a blessing for you. You know, So wherever you have source rock, that is where I find the hydrocarbon. Hence, it becomes the reservoir. And hence you don't essentially need a cap rock because it is so tight that the hydrocarbon cannot escape. It cannot, or you can say, I mean, it will. The migration rate is so slow compared to the conventional system that it cannot escape. So the same rock actually act as source rock, reservoir rock, and cap rock. Okay, because the permeability is extremely low. But on the other hand, because the permeability is low, you are not able to essentially take it out as the conventional hydrocarbon. Okay, that you drill it, and then you kind of pump it out. That is not going to happen. That's why you have to take the help of horizontal drilling. Horizontal drilling because you want to increase the surface area of the well, yeah, and you have to do hydraulic fracturing. Okay, because you want to enhance the permeability. Okay, so low permeability is blessing in one way that it doesn't allow the hydrocarbon to move away from where it was created. But low permeability is also is problematic from a production point of view because it is low permeable. You have to take the help of hydraulic fracturing. Is the point clear? Can just someone tell me how low permeability is acting in both ways for shale gas? Ratichi, is that clear?
Yes, sir.
Okay. So here is a comparison between shale gas and conventional gas reservoir. So in a conventional reservoir, of course, you need a reservoir. So this is reservoir. This is source rock. This is cap, right? And then you can drill a simple vertical well. It's no problem. Although in conventional wells as well, conventional reservoir also you drill, horizontal wells. That's not the thing. But you can still take out oil and gas by drilling vertical wells. But you don't perhaps need to do fracking. But here, for the shale gas, yeah, this is irrelevant. Seal is irrelevant. I don't really need a reservoir. Okay, you can essentially take out the hydrocarbon itself from the source rock, but you need to drill. You must drill a horizontal well, and then you need to frack. These are fracks. Okay. So, what are the good things about shale gas? It's plentiful. There, I mean, any layer of shale which has gone through certain oil and gas window must have plenty of gas in them, okay? Or shale oil in them. So because you don't really need that beautiful conventional system to fall in place. Hence, you can essentially get it from any shell that has gone through such maturation, which has enough organic matter. And I can tell you there are plenty of such shells around the world. Okay, because it is gas, it is cleaner than other fossil fuels like oil. Okay. Because it can be shallow as well. It has monetary benefits as well. Shale gas wells are not very expensive. Okay. Then, say for example, if you want to if you compare an well which is drilled for shale gas onshore, okay, to something which is drilled in the Gulf of Mexico deep water, the it's at least 25 times more expensive. So yeah, it's easier. It's the operation is also safer. You don't deal with a lot of pressure and all. So it creates a lots of jobs because you drill a lot of wells in engineering, surveying, construction, earth moving, equipment manufacturing, service repair, environmental permitting, water transport, wastewater management, servicing. It's good for the economy. It's low maintenance. Okay, so these are all good things about shale gas or any, for that matter, any unconventional reservoir. Uh, So most critics actually support the production of natural gas from shale. So so all the Greenpeace movements are kind of in support for shale gas. Okay. Analysts expect gas will greatly expand worldwide energy supply. Okay. And there is enough shale gas to support the US gas needs for next 90 years. That is a very fundamental statement, and that is also true for India. We have so much unconventional reserve, both in terms of coal bed methane as well as shale gas, that it can support us for a long time. So it really has some potential. Okay. Okay, so I stop it here, and we will continue with shale gas and tight gas in the next class. If you have any question, please ask. Anyone, any question, by the way? Okay. Is this batch really shy, or am I not able to come across properly? Am I missing something? Can someone, Nidul, is everything clear to you what I teach?
Yes, yes, sir. It was clear.
Is it boring? Do you find it
N-
boring?
No, sir.
No.
No, sir.
So why the class doesn't respond? I don't
I
like when the
don't know,
students
sir.
are really silent. Either you have understood it all or you have not understood it. But looking through your presentation, it seemed that you have done a good job, so you have understood. Maybe this is too simple for you. That could be the reason. Is that true, Nirul?
I don't know, sir, but it was like
It's
understood.
okay for you. Understandable. Okay, Shivani, tell me what is going on, because you interact. Let me ask why the other students do not interact. Shivangi, sorry. Do you find it hard, easy? How is it for you? Yes, I think she has left somewhere. Let me ask my old students few. Are you there? No, he is not there as well.
Sir,
Yeah, what is going on, man? Why are not students interacting?
sir, clear is clear, sir.
Is that the reason? Then I am happy. If
Yes,
not,
sir.
please do let me know. Okay, I want what this to be clear to you. Okay, then that is the thing. I have nothing to say. I will stop the class today. I'll see you tomorrow. Bye.